Welcome to section 12 of KMF new 170 puzzle. Let us start with the first question. How many integers between 360 and 630 are there such that they have odd number of divisors? The condition that we need to find out number of integers that have odd number of divisors. Suppose we have taken the even number of divisors. It could be 2, 4, 8. Now, to have odd number of divisors, we can take the square numbers, the perfect square numbers. So, divisor of a number, suppose 360 divided by 1 equal to 360. And now, if a number is perfect square, then it will have another number. For example, 4 is a perfect square and the square root is 2 and 2. 2 square equal to 4. So 2 and 2, there are two integers and 4 divided by 1 equal to 4. So 1 is another integer. So total is 3 integers here. That are the number of divisors. So we need to find out how many integers between these numbers or integers have odd numbers of divisors. What are the steps? Let us see. Step number 1. Find out minimum and maximum perfect square integer. Step 2. Take the root. And step 3. Find out the number of integers. That is the highest number minus the lowest number plus 1. So the smallest square root between 360 and 630 is 361 and the square root of that number is 19. Similarly, the highest square integer is 625 and the square root is 25. So total number of integers would be 25 minus 19 plus 1 equal to 7. So our answer is option E. Set S consists of all the integers from 1 to 100 inclusive. Which of the following sets contains the greatest number of integers? Here is a trick or rule that the smaller the number within the same range, the greater the number of multiples. For example, between 3, 4 and 5, 3 will have the largest number of multiples. Okay. So within 1 to 100, there are 33 multiples of 3. So between A, B, C and D, I mean option A to D, option A has the most numbers of multiples. Notice option D considered multiples of both 3 and 4. It's not that 3 or 4. So remembering this case, option A will have the highest multiple between 1 to D. Now come to the next option, that is E. So the integers of P that are multiples of either 4 and 5. Actually, it will be 4 or 5 because they have either, right? So there are 25 plus 20 minus 5 equal to 40 multiples of option A that are 4 or 5. So how have we found it? 100 divided by 5 equal to 20 and 100 divided by 4 equal to 25. And we have just take difference from the highest number of integers, that is 5, and we get the 40 multiples. So our answer will be option E. Let n be an integer greater than 3. If the remainder is 1 when n is divided by 3, then n square plus n minus 2 must be a multiple of what two-digit integer? So at first we need to find out what is the n. So n is greater than 3. Let's say n equal to 4, and we are given that remainder is 1. So 4 divided by 3, we get the remainder 1. Now n is 4, so 4 square plus 4 minus 2. We have set the equation, that is n square plus n minus 2, and we get 18. So our answer is 18. A certain desk calendar shows the number of the day of the year and the number of days remaining in the year. If the calendar shows 1 by 364 for Saturday, January 1, what does the calendar show for the Tuesday, that is 20 weeks after the first Tuesday in January? This is a very tricky math and easy also. So notice January 1 is Saturday and we need to find out number of days for Tuesday, that is 20 weeks after the first Tuesday in January. Okay. Now, what are the difference? What are the number of days between Saturday and Tuesday? 4 days. Saturday, Sunday, Monday, Tuesday. So we need to find out Tuesday, that is 20 weeks after the first Tuesday. Now consider the first Tuesday, that is currently number 4. Consider it the first date of January, that is January 1 and not January 4. Okay. Now calculate the 20 weeks in days. So 20 multiplied by 7 equal to 140 days. Now remember, you have considered the Tuesday, the first Tuesday, as January 1, and in reality the Tuesday is actually January 4. So now add 4 with 140. So we get 144. So our answer will be option E, 144 divided by 221. Why 221? Because you need to minus 144 from 364. Okay, let's move to the next question. When positive integer n is divided by 53, the remainder is 21. And when positive integer p is divided by 53, the remainder is 25. What is the remainder when the product np is divided by 53? So there are some strategy to use those for such problem solving. So in this case, we are given the product of np and we need to divide it by 53 and find out the remainder. And what are we given? We are given that n is divided by 53 and the remainder is 21, and p is divided by 53 and the remainder is 52. Now notice the product is np, so you can multiply the remainder, that is 21 multiplied by 25. So we got 525. Now divided by 53, we got 9.91. So consider only the whole number and multiply it with the divisor, that is 53, and we got 447. Right? Now take the difference, that is 525 minus 447 equal to 48. So the remainder is 48, and that is the answer. Now if the questionnaire, the remainder when the summation of n and p is divided by 53, you would need to add 21 and 25 and then divide it by 53 and then do the calculation to find out the remainder. In such way, you can do the same thing for the subtraction as well. Well, Let's move to the next question. Let n be a non-negative integer such that when 6n is divided by 75, the remainder is 30. Which of the following is a list of all possible remainders when 7n is divided by 75? Okay, so non-negative integer, it can be 0 and it can be any positive integer. Now we need to find out what n is, and after that we will be able to find out the remainder, all possible remainders. So let us write it in this way. This is the equation form. 6n equal to 75m. 75 is divisor, so we'll get a result, and that result is m plus 30. That is the remainder. And m is an even number, because if m is an odd number, it won't be divisible by 6n. And we won't get the remainder 30. Only if m is even, we will get such remainder. So similarly, let us write the second equation. 7n equal to 75m plus what? We don't know the remainder. We are going to find it out. So let us use some numbers. When m is 0, 6n equal to 30 and 7n equal to 35. How have we found out 7n? N equal to 30 by 6, right? So n equal to 5. So 7n equal to 7 multiplied by 5 equal to 35. As m is 0, so the remainder after dividing 75 is, it will be dividing by 75, the remainder will be 35. Similarly, when m is 2, then the remainder will be 60. And when m is 4, the remainder will be 10. When m is 6, the remainder will be 35. So get 35 in case when m equal to 0. So there is a cycle of 35, 60 and 10. So our answer will be option E. That is 10, 35 and 60. When positive integers k and n are each divided by 9, the remainders are 2 and 5 respectively. If k greater than n, what is the remainder when k minus n is divided by 9? So there is a condition. The condition is k greater than n. Now let us use the same style of equation. K equal to 9p plus R2. R2 is the remainder. And n equal to 9q plus R5. Now notice the condition is k greater than n. Henceforth, obviously, p is greater than q. Okay. So k minus n equal to, take out p as the common term, and p minus q minus 3. R2 minus R5 equal to R3. So minus 3, and that is divided by 9. So 9 minus 3 will get 6. So our remainder will be option E, that is 6. When n, k and r are positive integers such that n to the power k equal to 10r plus 3. So here 3 is a remainder. Which of the following could be the value of n? Okay. So this essentially means that when n to the power k is divided by 10, a remainder of 3 is obtained. Now we'll use a theta approach. We'll use the option test strategy and we'll replace k linearly with 1, 2, 3. So gradually we'll do it for all options. So 11 to the power 1 divided by 10, you get the remainder 1. So we need remainder 3, not 1. So in case of 11, we have tested with the power 2 and 3 and we have just rejected. Let us do same with option B, that is 12. We have rejected it also because we didn't get the remainder 3. For option C, that is 15, we also rejected that. Now, in case of option D, that's 17, we get that 17 to the power 3 divided by 10 and we get the remainder 3. So it's a match. Our answer will be option D, 17. It's a bit laborious, but we need to use such strategy. I don't know any such simple tricks to solve the question. If any of you knows, please let me know. What is the tens digit of 21 to the power 3 to the power 15? That is another laborious math. The exponential power of 21 is 21, 41, 61, 81, and 01 in 5 cycles. Okay. Now, the unit digit of 3 to the power 50 is 9. You can do it yourself and can find out the unit digit. You will get that that digit is actually 9. So 3 to the power 50 divided by 5 with a remainder of 4. Why have we divided it by 5? Because we get the exponential power of 21, that is in 5 cycles. So divided by 5 and we get the remainder 4. Now, the exponential power of 21 cycles to the 4th digit and the tens digit is 8. So our option will be, answer will be option E, that is 8. This problem is a little bit tricky and a little bit complex, but you need to do it to sharpen your thought process. If p is a prime number greater than 5 and if 5 is a factor of p plus p square, which of the following might be the remainder when p is divided by 5? So there are 3 conditions. P is a prime number, p is greater than 5 and 5 is a factor of p plus p square. How can we write p plus p square? We can write it as p, within parentheses we can write p plus 1. So p and p plus 1 are two adjacent numbers and they are multiples of 5. That is, p is multiple of 5 and p plus 1 is also multiple of 5. So now, only one of these p or p plus 1 could be the multiple of 5. Both, both can't be the multiple of 5, right? Now, multiple of 5 can end with either 0 or 5. So if p is a multiple of 5 and p is an odd number, why p is an odd number? Because only an even number, that is 2, is a prime number. Otherwise, all prime numbers are odd number, right? So p is a multiple of 5 and p is an odd number. So as long as the unit digit of p is 5, the condition is met. Now notice that p must be greater than 5. So we can't consider p as a multiple of 5, right? That's not feasible. p can't be 5. So let us move to the next one, that is p plus 1. It is a multiple of 5. So the unit digit of p plus 1 is 0 or 5. The unit digit of p will be, in this case, either 4 or 9, right? Because p plus 1 is a multiple of 5. So 9 plus 1 is 10 and 4 plus 1 is 5. So these are multiples of 5. So p is either 4 or 9. So since p is an odd number and a prime number, the unit digit of p is 9. So when a number with unit digit, that is 9, is divided by 5, we get the remainder 4. So our answer will be option E, that is 4. Well, some of the questions in this section are much tricky, and we need to use a little bit complex calculation as well. But I hope you will cope up with that. That's all for today. Thank you.